Hi, my name is Delaney Kirk, and this is Lab 2 Projectile Motion for Physics 2211. The purpose of this lab was to observe and analyze the motion of an object that is thrown and moves like a projectile. There are three models used: first tracker for analysis, and then GlowScript for the computational models. There are two kinds of computational models, one with only the force of gravity, and then one with the force of gravity and the drag force. The result of this lab revealed that the model with drag force and the force of gravity was able to more accurately predict the motion of the paper ball when it was thrown like a projectile. There are a couple key fundamental physics principles in this lab. First is the definition of projectiles, which states that an object under an initial velocity that moves due to only influences by the force of gravity. Newton's second law states that an object's acceleration is proportional to the net force acting on it. Therefore, F net equals ma. And then there's two forces involved in this lab. First is the gravitational force, which is the attractive force pulling objects with mass towards each other. And it can be described as 0, negative mg, 0. And then the drag force, which is a resistive force that opposes the motion of an object. And it can be described as negative b squared times v hat. And negative b, that is the drag force constant. And then the data that was used, here is the video that we recorded and plugged into Tracker. The system was defined as that balled up piece of paper. The surroundings was everything else, and then the initial conditions are listed there, and those initial conditions were obtained from Tracker. So the image on the left shows how the point mass was collected, and then the two graphs on the right were data obtained from Tracker, and then the data table below shows the time, the x distance, the y distance, and then there was also the velocity in both the x and y directions, and that's what gave us the initial conditions. Rest of the code for that model, there is a while loop, and then on line 79 it sets the drag force, and line 80 defines F net as the force of gravity plus the drag force, and then lines 82 through 84 applies the momentum principle. And this was the result of the gravitational model. The blue arrow depicts gravity, while that pink arrow depicts the velocity. And this is the position versus time in the y direction. And then here is the gravitational and drag force model code, which is the exact same thing. The only thing that changed is the proportionality constant, which was set to 0.015. And then also an arrow was included in that diagram for the drag force. So the blue is gravitational force, the orange is drag force, and again pink is the velocity. So when this data was all tracked together, you can see that orange is a gravitational force model, blue is from Tracker, and that green is the model with the drag force included. There were a couple possible sources of error, including human error, as it was difficult to keep the point mass in the same place each time, and then there were outside forces such as AC. So what does it mean? Terminal velocity is defined as when a freely falling object experiences zero net force, and here are the two velocity versus time graphs for our two computational models. Notice that in the gravitational model there's terminal velocity, however in the gravitational and drag force model it is not completely linear, so that it can't be terminal velocity. And then what if the object were thrown straight up with the same initial speed as in our experiment? The object would take a longer time to reach the ground as the previous experience because it has to travel a further distance. Thank you for listening.